Hi, everyone. I was thinking the previous presentations have been wonderful and shared everything. So I thought that perhaps I just crack some jokes and play some metal music for you. Now, I would like to talk to you a bit about the collision between two black holes. One is the digital technology, which is a big black hole for most of us. The other is construction industry, which is also a big black hole. And I'd like to thank Marta and Robin and the others because they share the future of the technology. So I'm only going to talk about stuff that actually exists today, just the things we have already. And I would like to reverse this and start by asking you a question. Is there anybody in this room who actually have a smartphone? Can you raise your hands? This doesn't work these days anymore. Let's reverse the question. Is there anybody who doesn't have a smartphone and are willing to share that in this context? Nobody? Because normally, in about 300 people, there will be a hand and somebody who for good reasons, don't have a smartphone. But that's where we are. So we have smartphones. Is there anybody here who doesn't have access to a laptop computer? I don't see any hands. Now let's do hands. Is anyone here who have, apart from your smartphone, laptop, access to another computing device, like a tablet or another computer at home, or anybody who has one more computer than just your cell phone? Or at least half. So it means that you're about 300 people. We're talking about having like 700 internet-connected devices, perhaps 800 in this group. I put what looks almost like an email address on the slide on the bottom left. I don't know if you can see it. And you see something are missing. That's my first email address that I got in 1984. And there are no dots because there were no domains, no .coms, no .sc, .uk. There were no dots. You couldn't have dots in the names even. Because at that time, there were only 700 computers on the internet. And when you had a new one, you had to suggest names, send a fax to US Department of Defense, and they will pick one of the names that were unique and fax back your IP address, and you were all set. So, I mean, to reflect on that, it's a 30-year history, and we've gone to that the entire net is now, you surpass that in this single room. And I think that's amazing. On a global scale today, we are right now having 2.5 billion active smartphones. And they are pretty much one-on-one. So 2.5 billion people, roughly 1/3 of the population on the planet, have a smartphone. And I think we run into a problem. Chris and Jim this morning talked about how their users shifted the expectations, that the mobile is now the reference, not the computer, but also that they shifted over time. Because we tend to think that smartphone is a smartphone. Hey, but we're celebrating 10 years from the big breakthrough. 10 years ago, Apple launched their iPhone, which kind of set off this industry. The iPhone 8 they launched this year is 1,000 times faster than the original iPhone. So during this 10 years, the capacity, the speed of it has increased 1,000 times, which means that you have a 3-year-old smartphone and think this is a reference what I could do with a smartphone. You are in danger of making bad decisions. So we kind of right in smack, and we don't have to speculate on the next. We can just look at the ones we have. Secondly, the white dots around the planet is the satellites. There are roughly 1,100 satellites right now orbiting the planet. This year, if I calculated correctly, we added almost 200 new satellites. So that's also kind of a growth curve. Some are discontinued, but there is an addition. And they provide us internet access, they provide us weather data, they provide us spy satellites, street view satellites. There are even some who are designed to kill off other satellites, but there are very few. We also have an internet highways below the planet on the roads and in the ocean, etc. Look up the internet cables underwater. It's amazing the amount. So what that means is that all these smartphones are connected. And if I try, there's something called ping. Every device on the internet can send a ping, which is basically hello to another thing, and it's going to answer hello. That's the only thing you always can do. If I ping a random Chinese website from my office with the shitty broadband we have, I have 150 millisecond average response time, which is 1/6 of a second I'll send a hello and get a hello back from China. So all these 2.5 billion devices are 150 milliseconds apart, which means that you in the room, you're not connected on the LinkedIn yet, but you are 150 milliseconds from each other. And it includes all the staff in your company, all the staff in your suppliers and their suppliers. It also connects you with all your customers, their family, their friends, their kids. It's 150 milliseconds away. Right now, that's not the future. And I think that, we have only started to scratch that surface of possibility when we can connect and how we can collaborate. We have email, we have messages, and we have, Snapchat and what have you. But it's not. There's a lot of things we can do with this technology. Last is do you know what that is? The thing on the upper right corner, I guess. Any guess? Do you recognize the animal? It's a camel. This is the last session. You should be able to speak up freely without feeling stupid. All right, it's a Google Street View cam. You've seen Street View, right? The pictures you can get of streets. Well, that's the typical camera. They have a smaller now, of course, but most of the pictures are taken on that. And yes, it is a camel because they did a mapping on the desert around the big pyramids in Egypt. 2 guys even tried to drag one of those up to the top of Mount Everest, but they failed. But I guess the new version is going to be easier. Google Street View database has a lot of information, pictures, maps, etc. Do you know how big it is? It's 3 petabytes. Do you know what a petabyte is? You have gigabytes, that's the thing you have in like your phones. Then 1,000 gigabytes is a terabyte, which is like a big laptop or mainframe servers, big. So a petabyte is 1,000 terabytes. This thing is 3 million gigabytes. The point of all this that I think Märta spoke about, the cost of a startup. If I have a startup, all of this is for free. It's terribly expensive, but if I do a startup, I don't have to pay anything to access and make use of this technology. Actually, to reach the 700 million iPhones, I need to pay $99 to Apple, and I get all the development tools, I get an account within App Store, I get all the tech to reach those 700 million. For the Google Android world, it's for free. So the startup is $99. A couple of persons working on the spare time during weekends can create and use all of this technology without a cost. The best example is the Pokemon Go. Oh, it's so last year. I'm sorry for talking about it. Did you ever pay Pokemon Go? The kids did, right? It's about $1 million development cost for that app because it's kind of a sophisticated app with a lot of graphics and stuff in it. But it uses all of this for free. Do you know how much money they made on that? First 8 months, they netted $250 million in revenues from a $1 million investment. So 250 times, which is, we talk about profitability, it's 25,000% in 8 months. That's the digital economy for me. And this is, I'm not talking about the future, this is what we have today. I think it's kind of fascinating. So for me, digitalization is not so much about the future, because I'm really bad at predicting the future. Because if I had in 1984 seen where the internet would be going, I would be earning so much money that you could never afford me to come to a venue like this and talk, right? Digitalization for me is doing things simpler, faster, and automatic using existing technology. There's so much we can do with existing technology. And for most companies, tech companies need to develop stuff, but I think many of us, we can make use of what's there. We don't have to invent a new technology. So the billion-dollar question for us is really, what is it worth to make faster, simpler, and automatic? And that's going to come to my favorite example right now, which is the construction industry. I came from the digital world. I did innovation projects for Volvo, IKEA, even product development for Microsoft, SEB, stuff like that. You use it. If you pay bills online today, I did that. So I've been part of a lot of that world during these 30 years. But then I was engaged by ALKAB to work with the relocation of 2 mining cities because the processes, they needed better ways to work on that. And then I was kind of in this construction industry. And so we started looking at what can we do with the construction industry. Construction industry costs in Sweden have doubled compared to the consumer price index. So, and it's not cost for land. People say, oh, the land is more valuable. This is just the production cost. And since 1983, it's been a doubling of multiple family homes. But basically, you can say it's almost since the 90s, the real doubling has taken place. And then you compare it with like cell phones, with all the cars, and with food and everything. So it's kind of, it's hard to understand why that has been. Is there a reason for it? I'm not going to go after the Swedish industry because it's a global problem. In the United States, believe it or not, construction industry have had 0 productivity gains since the Second World War. Compare that to agriculture. You're not going to go around dissing farmers anymore. They're really at this game. They have automated vehicles and stuff already. It's a 0 productivity growth. Of course, the productivity has increased, but it hasn't kind of paced with the increased complexity of new buildings because we have much more technology in buildings. We have much more demands on environmental energy control systems. We have much higher demands on material, etc. So buildings are more complex today. And we have increasing labor costs for safety, for education, etc. So you can say that the technology adoption in the history has paced with this cost. Not in Sweden. We lost like 50% or 100%, but in general. But we haven't gained it. And the industry hasn't really bothered. It just pushed the cost to people, to tenants, to people. So this seems like it's worth looking for stuff which we can make faster, simpler, automatic. And a bunch of people have come together because the industry is fragmented. There's a lot of different players. No single organization can individually change this industry because it's tied up with legislation, it's partnerships, you have different roles, etc. So it's rather complicated to change. But these are the people. SABO is the Swedish public housing collaboration thing. So it's all public housing, hyreslägenheter. We have a different system than in other countries. So it's not exactly social housing, but it's kind of corresponding. 1 out of 7 people in Sweden live in a SABO apartment. So they're kind of a big player. Tekniska Transkat, they are really good. They don't know much. They don't know much about construction, and that's why we're working, because we want to steal their experience from all the other industries. Basically, I don't know, how many people are from construction here? 1, 2, couple of people, yeah. We want to steal knowledge from everybody else, right? From car industry, from ship making, from, so that. And Tekniska Transkat is an important partner in that they know about these things. Veidekke is the 4th biggest construction firm in Scandinavia. Öbo is particularly in a small town called Örebro, but they have 23,000 apartments and they're pretty aggressive, so good to have the real people on board. Cementa is the biggest material supplier in Sweden and part of the Heidelberg Cement Group, which makes them a part of the biggest construction outfit in Europe. Forsen is a big project management firm in Sweden. So we represent 22% of all new home building in Sweden and a turnover of some $11 billion. So we think we have some small chance in doing things. So what is it worth making faster, simpler, or automatic? I know, we want to talk about automatic vehicles and self-propelling rockets, but let's talk about plumbers. It's not perhaps the most sexy thing, but we do need plumbing. This is a study by the Swedish HVAC industry, VVS industry, they studied 8 buildings and they measured all the plumbing work in the construction of these 8 buildings. And it's the industry itself, so it's not kind of me, the bad guy, I'm always the bad guy, who are saying you are working a certain way. They did the measurements themselves. Turns out 35% of the time, plumbers are waiting. They're waiting for stuff, they're waiting for someone else to do the job, they're waiting for access to an area. 35% of the time. Another 35% of the time is unqualified work. It means that they are looking for things on the site. Believe me, construction is not logistics as you have in a car industry. They're looking for where the things are. They are carrying stuff, unpacking stuff, they're cleaning. That's stuff that needs to be done. but you don't have to have a degree in plumbing. And plumbing is one of those. It usually is on the top of the shortage of professional workers. So it's kind of a big issue. 70% of the time is non-plumbing. And now we look at what they're actually doing. Half of the time they're in meetings. Samverkan is called in Sweden. I don't know what that co-work. It seems like it's a lot of little work. Mycket sam, lite verkan. On average, a plumber on a multi-family home spends 1 hour, 17 minutes per day doing the actual qualified work. Amazing. The bad part is that since 1989, when they last did this study, sorry, I'm looking for the time thing and they're changing it all the time. It's been down 30%. Productivity among plumbers in multiple homes is down 30% in 20 years. So what do you do then? This is the world's tallest wood frame building. It was completed last year in Canada, in Vancouver. A startup called CAD Makers, which technically is partnering with these guys, tried out some stuff they learned from the aircraft industry. So they had a plumber and a 3D CAD person would work together. This is software called Delmia. It's part of the Dassault thing. I think most of you know more about Delmia than I do. So they work and they're building the whole thing, basically. What are the parts? All parts are in 3D anyway, so you can, and they figure out, don't put that pipe there because you never get the heater in, etc. So they work together, trying out the best way to do it, what materials to go where, etc. For people outside of construction, it's like, oh God, we've been doing this since the 80s. But in the construction industry, it's kind of a new thing. And the good thing is that they also measured how the effect. And they would spend 160 person hours in the CAD room, and then they would build the entire technical room, Undercentral as it's called, in 200 person hours. The original traditional estimate was for 800 to 1,000 man hours. I shouldn't say man hours, it's person hours. So they're making a 60% time saving. They're also raising the quality because all the clamps are the same manufacturer. They know where everything is. They do a lot of work in the workshop instead of on site, so the materials handling, returns, and waste is much better. And of course, the quality is improved, not just in production, but also if you have a 3D model, you have an exact thing of what the building are when you are going to maintain it later. And of course, if I hadn't shown you the study of plumbers, nobody would believe that it was possible to make a 60% improvement in one small situation. So it's kind of this really simple start way. And I think that we have a good chance to drop the production cost of homes in Sweden with 50%. We're going to it's not going to be difficult to take away 50% of the cost. I think it's possible by adding on new technologies. I'm sorry, I should have introduced it. This is a scientific way to, describe what we're doing. That you need to plan ahead. When the new technologies are coming into this production mode, we can probably cut the cost even another 50%. This is all existing except for the two guys in the middle. On the top left, you have German Minda, who manufactures wood machinery. So it's like, I don't know exactly what, you make frames for like a complete sports arena. It's controlled by 3D systems. It loads, glues, unloads fully automatically. You can buy entire plants from Minda already today. So now we're in a position we can make fantastic wood things in any shape. Shape doesn't cost anything here. You can make individual buildings super cost effective in this type of machinery. And it's already available. The 3D printer you see there is actually 3D printing wood. And the experiment that was part of in Lycksele in Sweden, we were trying out what we could do with the local industry there. So it's like a glue and wood, and when it's heated, you can move it around and glue it together, then it hardens. So you can make 1 million sprays, We can make replacements for old buildings very cheaply. That's available today. You can buy it. On the right thing is a robot from ABB. There are a few robot guys from ABB here. They made these mesh robots for the concrete industry. It makes rebars, armering, so it's kind of, it prints metal. So it's like a welder, but it can make shapes. So you can take any 3D shape, it's going to make a mesh of iron, and then you fill the concrete into it. You don't need the forms, so you save a lot of material. Again, you can make any shape without additional cost. It's a wonderful product. You have the ABB Yumi robot. You probably saw it on the ads for Elgiganten this, I think it was Elgiganten, the last Christmas, which is not dangerous. Because robots, in construction sites, you need to have people and robots. And if you would walk into the Tesla factory, you would be killed within seconds because these big robots are strong and they don't pay attention to you. But the Yumi robot, it knows about people, so it's not dangerous. It's going to be careful. It can stand on a production line. And it's a critical thing in construction because we will always, at least for the upcoming 5-10 years, have people on site. In the middle, I love this. It's a startup. Okay, it doesn't work yet, but almost. The two guys, they're doing a robot for automatically put up dry sheet walls, gipsplatter, drywall. So it kind of works in the night and put up the drywall. And it's kind of it's in Stureplan, one of the most fascinating places expensive in Stockholm. They're doing this. And automatic vehicles are using. I'm out of time because I haven't really, this been flipping on. How am I for time?
Yeah, go on.
I'm okay.
Yeah.
It's been saying 0 here for quite a while.
Yeah, very strange.
Okay, but I'm good. It's not all right. Rio Tinto is one of the world's biggest mining companies in the world. They are in Australia. They're 20 times as big as LKAB, as much as we love LKAB. These are autonomous vehicles. They have for 10 years had these in production. And since 5 years, what did you do 5 years ago? They have 3 full mines where all these transport vehicles are completely autonomous. They have one person surveilling all of these movements. If you don't believe me, you can look at the tracks. They're absolutely straight. You never see that when people drive these trucks. And I think Leif talked about this morning about it. I know in Boliden, where they have these types of trucks with drivers, they only employ women. You would never, as a man, get a job there because you'd use too much fuel and you brake too much. These things are much safer and use even less fuel than women can drive with them. And that's been in production. I don't see any construction people working with that. But inside, the industry area, it's not the same as going in the streets in the town, but it's a well-tested and approved technology inside construction sites. Wow, the last picture is really to remind us why we are doing this, because I think we had this day with wonderful technology. It's going to be so much better in the future, and it's even threatening some of us are going to lose our jobs. But for me, this is kind of why I'm interested. This is a design concept study I did for LKAB. We brought together a lot of clever people. We had dialogues with the citizens, with the schools, with the future engineers who they want to employ. The engineers want to move to Shanghai, and they want them to move to Kiruna, so it's kind of a challenge. Then we put together this. That's almost like this PLM thinking. We had the architects, the planners, the estimators, the engineers, all working, iterating. These super detailed buildings. They're all wood frame. We looked at wood frame production of parts in Austria, finished manufacturing in Estonia, mounting, putting things together in old shipyards in Finland. We even calculated exact space. We could shift stuff from the harbor in Luleå up to Kiruna. So we iterated that. So we ended up with this. We could build this, and we would be down at the rent cost, which was acceptable to Hyresgästföreningen in Norrbotten, which is a kind of affordable housing thing. So I think that the possibility of creating a wonderful, environment to live and work in, that's also cheap. That's kind of, for me, the driver and why I'd like to work on this. So, thank you.
Thank you. Just one short question, Lars. Another reason for the bad productivity in the sector usually is said to be that the competition is not that really good, and they make a lot of money, the few large players that there are. So my question is, are there any pressure on the industry to change, or are you like fighting against ghosts here?
I think that most of these companies it's a very local business, and it's protected by protectionism, by trade unions, and even by legislation. Let me give you a weird example. In Sweden, if you build a number of apartments or rooms that open up to a corridor, if there's an emergency, everybody have to get out. So in Sweden, the legislation says you have to have the doors open out in the corridor so people can get out of the room. In Norway, there's a legislation for people in order to get out. The doors have to go into the room so it doesn't block the corridor. Right? So you have the same problem, you have the same kind of situation, same people basically, but you have two technical, and these are in legislation. These are in code, you cannot change them. So it's extremely local. But there are entries. Cisco is, if you look up at these type of roofs, there are billions of electrical cables. Cisco launched something they call the digital ceiling, where they replace this with Ethernet, the stuff you connect computer with. They drive 60 watts of power in it. They could attach any light, any control device. They cut the cost to half. And that's an international product. It's a global standard. So there are tech companies coming in as a drive for it, but there's also a lot of protectionism.
Okay. So it's new players are going to change the industry.
Oh, yes.
Thank you very much.
Oh, thank you.